everyone. I hope you got your snacks, settled in, and we're gonna talk about. So I know the post-construction BMPs. I know that the previous speakers, David, Nikki, and Bobby, spoke about temporary BMPs, which are erosion and sediment control, and we are going to focus on this part of the session. Going to focus on post-construction. Carrie here, Carrie and I are going to talk about concept of construction, Kaʻahumanu drainage improvement project. So this is the agenda for the day. Before we dive into the actual case study of Kaʻahumanu, I wanted to do a switch rule on you guys and kind of talk about the post-construction BMP requirements that we already have. I don't know how many of you guys are designers, engineers, contractors that have done post-construction BMPs. Okay, pretty good enough hands. So I think this might be like a basic presentation for you guys, but for the others, it's going to be a refresher of requirements. I'm going to show you some resources that we have on the post-construction BMPs, and then just share a couple things that Maui District is doing in implementing LIDs. And then Terry is going to dive into the case study, and he's going to talk about the design goals, look at the construction process, and then he'll finally share some lessons. So why do we need this manual, right? As the previous speakers have iterated, there is an MS4 permit requirement. So HAR 1155 SNXK, Part 6 has a requirement specifically related to post-construction BMPs, and it requires both Oahu and Maui DOTs who have MS4 permits to develop, implement, and enforce the post-construction BMP program. Okay, so, and that program is designed specifically to look at new development and redevelopment projects that are disturbing over an acre of land. And at a minimum, the requirements or the things that DOTs have to do is three things. They have to have some sort of process, regulations, requirements in place to install, implement post-construction BMPs. They have to provide some sort of design guidance of what these BMPs are going to look like and what they're going to put in ground. And typically, they have to provide water quality treatment and mimic pre-development hydrology if possible, so LID. And then last but not least, they also have to plan for operations and maintenance of BMPs once they're installed. So the manual itself is a document. Here's the cover page. It's been effective since 2022. It's a statewide document, and it goes into detail about what the requirements are, what are the different options for BMPs, and what are the criteria, which projects need implemented. So because this is a refresher, we're going to go over some key definitions and basic stuff. What is a post-construction BMP? It's basically a practice or a device that is invented to either provide water quantity treatment or water quality treatment. It can be a couple of different things. It can be low impact development or LID. It can be source control or treatment control. And it's also synonymously used or interchangeably used or called permanent post-construction BMP or permanent BMP. And what is low impact development? Low impact development is a land planning and a design approach with the goal of mimicking pre-development hydrology. So you're trying to put back, so if you're going into a project, you're trying to put back, and you're going to include impervious, you're trying to have the same amount of water what it was discharging before construction and post-construction. So that's the goal. And then EPA has been using green infrastructure as a synonymous word for LID. So besides MS4 permit requirements, why should we do this post-construction BMPs? And then I know the previous speakers have reiterated that there are a lot of benefits of post-construction BMPs. Primarily, they include environmental, which are listed here, but they can also be social and economic benefits. So for environmental, the obvious one, right? We're going to provide water quality. We're going to reduce the runoff. We're going to reduce the risk of flooding. where we could potentially do erosion mitigation, reuse, capture and reuse, groundwater recharge. The plants in the post-construction BMP can absorb carbon and provide air quality. They can reduce heat island effect and provide other range of benefits, including but not limited to energy savings, wildlife, supporting wildlife habitat, and climate change. And regarding the social and economic benefits, the social benefits would be they can provide aesthetic factor to communities and neighborhoods and provide opportunities to engage the public. And then economic benefits would be they can reduce the cost of flooding, reduce the infrastructure costs for wastewater, and potentially provide jobs for installing and overall maintenance of these construction. So continuing with our key definitions, so what is new development and redevelopment? So new development is any construction of new impervious surface where there was nothing to do with, there was not impervious or pervious surface. So for DOT projects, the new impervious surface is intended for vehicular use only. So that includes road construction, widening, realignment, interchanges, things like that. However, it does exclude impervious surfaces intended for non-vehicular uses. So if you're planning a project that has bike paths, sidewalks, shared use paths, those are not accepted as new development. And then for redevelopment is alteration, reconstruction on existing pavement, right? So you're doing something to the existing pavement with your project. And then the exclusions include if you're doing pavement separation treatments like cold planing or mill and fill. So the manual differentiates between MS4 and non-MS4 permit areas. Because of the MS4 permit requirements, the MS4 permit areas, which are Oahu and Maui, will have a more stringent programmatic requirements under the manual, and the non-MS4 permit areas, which are all the other islands, Hawaii, Molokai, and Lanai, will have less requirements under this manual. There's also differentiation between the public and private projects. Should be very obvious, right? Public projects are anything that's funded or administered by DOT. Private is everything else that is not administered by DOT. Private projects are necessarily not just private. It could be like county projects, county Maui, Kaʻahumanu, or other state agency projects. Public projects meaning could also mean projects that are either engineered by private engineering companies and could be constructed by contractors, not just DOT. Okay. And then public projects are typically in the public right of way, and then private projects are either located adjacent to the right of way or they drain or discharge runoff onto the right of way. And the reason why we target the private projects is they usually come in for some sort of permit because they have an encroachment on the DOT right of way or roadway. So they either need a permit for work or they need a connection permit or a discharge permit, and they come into DOT, and that's how the project will be reviewed to see if they need to be considering those construction. So the criteria is dependent on, is triggered based on either the disturbed area or impervious area. And again, as we talked before, it's different criteria for MS4 and non-MS4, and public and private. So if you're a public project in the MS4 area and you disturb over an acre, then you are required to implement the light. And if you're a private project in the MS4 permit area, which is Maui and Oahu, and you have the potential to discharge into the DOT right away, then you may be required to implement the And then for the non-MS4 areas, which are the outer islands, if you're a public construction project that results in 1 acre of new impervious, it's required to implement a LID, and then for private, it's the same requirement, 1 acre of new infrastructure. So note that it's the difference between the disturbed and the infrastructure. And then for private projects, DOT will verify that these private projects are implementing the BMPs, right? And it only looks at the discharge from the private project onto their right of way. If you have a big subdivision and only a portion of the project is discharging to the DOT right of way, DOT is only going to look at that part to see if necessary post-construction BMPs will be implemented. And if your private project does not discharge at all, like somehow you're lower than the roadway and you're not discharging, then DOT, and you still coming far from it, DOT will still review the project, but they will most likely, at their discretion, accept if you meet the respective county regulation. Meaning, you still have to comply with either County of Maui or City and County of Honolulu requirements, and then DOT will issue it. So they will look at it. And then all private projects will be reviewed, and DOT will make sure that their comments are added before they issue a permit. And then there is a caveat of priority project. A priority project is a project that has potential to discharge pollutants. So it could be a stormwater hotspot, a parking lot, a maintenance base yard. So wherever there is potential for additional pollution or a discharge to a central water body, DOT has discretion to require post-construction BMPs regardless of this criteria. So if your project falls under priority project criteria, DOT may ask you to do either LID or post-construction. So are there exemptions to the implementation? Of course, right? There are exemptions. I'm not going to read the list because this is just an excerpt and it doesn't provide a complete list. If you do want to look at the complete list of exemptions, please look at the construction BMP manual, and then we also have a post-construction BMP design checklist, which includes all the exemptions as part of the checklist. So you can run down through the checklist and you can qualify. You can see if your project qualifies for an exemption. And just because you think you are qualified for an exemption, it's not an automatic exemption. Still needs to be reviewed by DOT so they can make sure that you do qualify for it. Again, there's a separate checklist for MS4 and non-MS4 areas. So this is what a post-construction BMP design checklist looks like. The first part is applicability part, which basically runs you through the list of exemptions. It's pretty self-explanatory, and you can run through it. If you have any questions, you can always ask us. The project proponent, typically either the designer or contractor, fills this out, submits to the DOT, either for a private project, and or if it's a private project, whoever the private project proponent provides it, if there is something. In order to meet the requirements, there are a couple different types of post-construction BMPs you can implement within your project. As part of the 2022 manual revision, DOT wanted to prioritize low-impact development BMPs, which was, finding that DOH gave them to see if they can prioritize low impact. So the first choice, obviously, is low-impact development. So if you have a project, you're meeting the criteria 1 acre disturbed or impervious, you need to implement LID. Try to implement LID first. So look at LID first, see if you can do some sort of retention on your site, and if that doesn't work, then your next choice is the traditional non-LID, which is your filtration, your sedimentation ponds, and then the last option, if that's not feasible, is your proprietary or manufactured treatment. And then at this point, I want to give a shout out to all our vendors out there. So if you want to look at proprietary devices, please talk to the vendors in the back, and then they are your resource for you. Reach out on what are the new latest technologies out there and what can they do. And then provide you with, solutions for you, tailored for your site or project. Here's some common examples of LID treatment control BMPs and a list provided in the manual. The typical ones that you see on the highways, the photos are the typical ones that you see on highways, is basically use the exhibit rail, enhanced rail, bioretention, permeable pavement, and buffer strips. And then these typically include retention, right? So water is stored in them and then treated and released, and either through infiltration, bioretention, evapotranspiration, or filtrate. And then we have the non-LID treatment control BMPs, which the most typical one that we have is the traditional one we have is the detention pond, which is very common pond, and then it provides treatment through settling, and then there's some proprietary non-LID treatment control BMPs that I've shared here that were installed as a on DOT project, but this does not necessarily mean that DOT is endorsing these projects or they have an approved list. They do not. So DOT will review any proprietary BMPs that you guys, designers, contractors want to install. So feel free again to go talk to the vendors, find out what new things are happening in that arena, and see what best suits your construction site. In terms of design, there are two approaches, right? There's a volume-based design and a flow-based design. So if you are planning, for example, a bioretention facility, you're going to do a volume-based design through retention. And if you want to do, for example, a vegetative swale, you will be capturing pollution through filtration, and it will be a flow-based. So these are the equations on how to size your BMPs if you're doing either volume-based or flow-based. I'm not going to talk about the sizing. It's, you guys can go into the manual and figure it out. Just want to note that the treatment area here is an impervious area. And there may be site constraints, right? In terms of space, slope, lack of right-of-way, impact, structural foundations, environmental, cultural constraints. So it may not be possible for you to do LID or construction BMPs, or you may not be able to do them to the maximum extent practical. So you could maybe treat a portion of your site, but not all of it. So that is possible. So how do you know how much you have to treat, right? So in order for you to figure out how much you have to treat, you have a required treatment area calculation, which essentially looks at how much new development and how much redevelopment is in your project. So if you have a new development, an acre, you have to treat the whole acre, and if it's a redevelopment, you're going to treat a fraction of it depending on where you are. For MS4 areas, it's 0.25 is a fraction, and for non-MS4, because of the lack of resources and funding for those areas, it is 0. So now we're talking about a scenario where you have your required treatment area, you know what you're doing, right, and you can't meet it. So then DOT highways came up with an alternative compliance program. So this is a program where if you're unable to treat or provide water quality for the impervious area that you're either new impervious, new development, or your redevelopment, you're not able to meet, then you can request variance, and there will be an alternative compliance, meaning DOT will have to put a post-construction BMP somewhere within the same watershed, or they would have to take a different watershed with either equal or higher area. And please note that the alternative compliance program only works for public projects, meaning DOT highway projects. So if you are a private project, DOT is not going to allow alternative compliance. If you don't want to track that, the tracking is only for public projects. So DOT has a water quality credit tracking program, so they're tracking the impervious area, treatment area, credit or deficit. So if any project treats more than what is required, they will generate a credit, and if they treat less than what is required, they're going to generate a deficit. If you are going to generate a deficit, if the project is going to generate a deficit, the designer shall submit a variance request. And DOT has to approve that, like, the designer has exhausted all the options to implement LID, treatment control, and manufactured treatment devices. So, like, nothing is feasible, or, you know, whatever partial credit is actually justified. Here are some resources. We have stormwatermaui.com, where you can go to the resources section and check out resources for designers and contractors. It includes both construction and post-construction BMPs. This is the post-construction BMP section. It has the manual, the checklist, the workshop, Q&A, some videos for training. And then Oahu has the Stormwater Hawaii website. Same thing, they have a designer and contractors resource on there. Currently, Maui district is doing public LID PCBMP projects, and we have erosion control issue at Stable Road and Kaʻahumanu that's being addressed by a bioretention and vegetated swale. This project is currently under design. And then the second project we have is under construction right now, which is the Kaʻahumanu Avenue Drainage System Improvement Project. And with that, I turn to my partner, Terry.
Thank you, John. Can you hear me? No. Our case study today is the Kaʻahumanu Avenue Drainage System Improvements Project. This project is addressing erosion issues at Maui Police Department. The unpaved area you're looking at is entirely within the DOT right-of-way between Kaʻahumanu Avenue and the Wailuku NPD across from Fort Memorial. This is a depressed area that collects surface runoff from West Kaʻahumanu Avenue before entering the existing MS4 system. The stormwater is then conveyed under West Kaʻahumanu Avenue and discharged into Kaʻahumanu Park via 78-inch storm drain. The area immediately surrounding the existing drain inlets are moderately steep, which contributes to sediment entering the MS4. The traffic cone in the picture marks the first inlet. Site conditions include existing utilities within the area, such as power poles and existing storm drain manhole, which receives a 24-inch drain line from NPD's parking lot. It is the high point at the site, with flows being directed toward each of the drain inlets in close proximity to a fence line. The subsurface soils at the site are mainly comprised of medium dense to dense sand, with traces of silt and gravel. Sandy soils in the area have a significantly higher infiltration rate. Infiltration tests were conducted as part of the geotechnical soils investigation and calculated infiltration rates at each test location, and both exceeded 24 inches per hour. Design goals of the project are to implement drainage improvements, including LID post-construction BMPs to protect exposed slopes, prevent sediment loss caused by wind and water erosion from entering MS4, reduce stormwater quantity, and improve stormwater quality. In general, our design focused on creating basins around existing inlets to limit the amount of dirt and sediment from entering into the drainage system. The site was split into separate parts to maintain drainage patterns. The surrounding grades and proximity to the existing fence and utility poles constrain the overall size and general shapes of the basins. Due to the high volume of runoff, riprap aprons were proposed to help provide energy dissipation for incoming flow to each of the bioretention basins. A vegetated swell was designed to help convey the flow to basin number 2 due to it being a longer distance away from the high point. Scope of work includes site grading, retrofit of existing drainage structures, construction of bioretention basins and grass swale, installation of temporary irrigation system, soil amendments, and landscape. On the left of this plan view, it shows the riprap aprons used to slow the velocity of the runoff waters as it enters the site to help control erosion and minimize sand and silt from entering basin number 1. Then the grass swale leading to basin number 2. During intense rain events, the excess stormwater flow will enter the graded inlets and into the MS4. Here's the original plan view of bioretention. The landscape design includes peely grass around the new code tree, Pohina in the basin interiors, and Bermuda grass wrapping the perimeter. Here's a plan view of basin number 2 and the grass swale leading to it. Again, the landscaping details with peely grass around each of the new code trees, Pohina in the basin, and Aki grass, which is dissimilar to Aki shown on the plan, used in the slope swale leading to the basin itself. Plan details. The site is relatively dry and soils have very high infiltration rates. The bioretention is designed with a 4-foot thick bioretention soil mix layer that provides infiltration into the native soil. The bioretention soil layer is designed to filter pollutants from stormwater, infiltrate the water into the ground, and support healthy plant growth, and provide a medium for biological and chemical treatment processes that break down pollutants. The engineered soil, a blend of sand, compost, and topsoil, acts as a natural filter, reducing flooding risk and protecting water quality by removing sediments, nutrients, and other contaminants from runoff before it reaches our waterways and groundwater. Plant media mix design use several native plant species to act as a living filter to mimic pre-development hydrology, also diversifying plant species to avoid loss of vegetation in the event of pests. Drought-tolerant plants were selected to promote sustainable landscaping and to minimize irrigation needs. Moving on to project timeline, actual construction time for this project was between February 3rd and March 13th, including landscaping installation establishment. Currently, we are in the ongoing extended landscape maintenance period. Here's a short video of the project progress during its construction. I would like to take a moment to thank Maui Photo Builders and PA Gardens for their dedication, and especially Harry Curious for his leadership and commitment to quality. Your care and teamwork truly made this project a success. Lessons learned. I will go over these in the next few slides. Limited access, manhole conflict and redesign, grass species, issues with bugs and native plants, irrigation, long-term maintenance, and seasonal variation. Limited access. Because of the narrow site access, the contractor sequenced the work in phases rather than completing the civil portion all at once. Each stage included clearing, demolition, installation, and immediate plantings and irrigation before moving forward This approach minimized soil compaction, maintained progress, and ensured the project met specifications despite access limitations. The existing drainage system at Basin 1 varied from the conditions shown on the plans. The storm drain manhole is a 9-foot by 9-foot concrete box that would end up being exposed and unsightly. Basin 1 layout was adjusted to avoid the storm drain manhole under PCD number 1. In 2 weeks' time, DOT was able to coordinate with the designer and the contractor to redesign the borrow retention basin without affecting the job schedule. While the basin footprint was reduced, the designer tried to increase the width of the swale. Here you can see the layout created by the contractor, by the project manager, explaining to us what they found on site, with what that structure size would be, and that it would be about 18 inches exposed after the basins were excavated. And that's where it would be on site. As you can see, an added benefit to the redesign provided an access lane for maintenance of the storm drain manhole. On the left, you'll see more. Here's some progress photos. And there you can see the access lane going to the storm drain manhole. The grass swale leading to Basin 2 was widened to accommodate the decreased basin size, adding 2 feet of width to help regain the loss of treatment provided by the original basin. Grass species and name confusion. The site was inadvertently planted with Aki instead of Maui Aki. The names and intended use of both appear quite similar. Maui Aki is a general term for grasses, sedges, and some herbaceous plants. It is usually found in inland and rocky areas. It offers drought tolerance and erosion control as a ground cover. Aki is a name used for seashore drought seed, a grass that grows on sandy beaches. It also offers drought tolerance and erosion control as a ground cover. Aki typically hugs the coast and spreads like a mat, and Mahu Aki grows inland in bunches. Aki also derives a majority of its water intake from moisture in the air from being along the shoreline. DOT, in collaboration with PBR Hawaii landscape designer, conducted a post-planting site inspection and did not take any exceptions to the plant exchange. Here is a list of potential infestation by bugs on the species planted at the site. Coal trees can get leafworm, which is a caterpillar from a moth, and can defoliate and damage the trees. Aki and Pohina are prone to ants, scale, mealybugs, thrips, and aphids. Peely grass is generally pest-free. We have observed infestation of coal trees and some minor issues with bugs, but with Keegart's help was able to address those issues. The contractor installed a temporary irrigation system for watering and ensured it was operational throughout the 3-month planting period and the plant establishment period. Due to high installation and future maintenance costs, permanent irrigation was not considered. During the establishment phase, the contractor will continue caring for all trees and plantings on site, including regular watering, mowing, weeding to ensure healthy growth. All post-construction BMPs will require inspections and maintenance. Operation and maintenance and a plan has been provided by the designer. Next, we have seasonal variation and dormant vegetation. This is in an area that is mostly dry. That's why the species particular species were picked. In fact, this year, you know, we've been in quite a drought season. In fact, I can only count 5 times this project has actually seen rainfall. The largest rainfall we had was the week before the project got underway. DOT will continue monitoring post-construction BMPs to ensure they are functioning as designed, paying close attention to plant health. Benefits of LID implementation and erosion mitigation. In closing, DOT successfully addressed the site's erosion issue. By comparing conditions before and after construction, soil loss was reduced by about 5 tons per acre each year, with basin number 1 accounting for 4.25 tons and basin 2 accounting for 3/4 of a ton. Benefits of LID implementation at Kaʻahumanu is improved water quality, and a net credit to the water quality bank is 4.79 acres for EL watershed. That brings me to the end of my presentation. It's an exciting time for all of us working in the stormwater sector. Thank you for taking the time to be here today, for your interest, and for your dedication of being part of the solution.